Hello friends, this video on acid and base part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study acid-base indicators, reaction of acid and base with metals, reaction of acid and base with each other, reaction of metallic oxides with acids, reactions of non-metallic oxide with base, common acid and base, how strong are acid and base, importance of pH in our life, chemicals from common source. Before we even start the chapter, let's recap what we already know from our previous classes. We know that acid are sour in taste and change the color of blue litmus to red. These things we know, right? We have learned this in our previous classes. We also know that bases are bitter in taste and they change the red litmus to blue. And we also know that some of the natural indicators of acid base are litmus, turmeric, etc. Right? And we also know that litmus is nothing but a dye which is extracted from a plant, and litmus is neither acidic nor basic. Its color is purple. So now let us go ahead and define acid. What is acid? Acid is nothing but a solution that has excess of H plus ion. Please note, it has excess of H plus ion. So it is a solution which has excess of H plus ion. And they are sour in. So there are two properties of acid we know. First thing, they are sour in taste, and second thing is they have excess of H plus ion. Please note this is very critical, this excess of H plus ion, because chemically we define acid as nothing which has excess of H plus ion. So any solution that has excess of H plus ion will be acid. Correct? Extra H plus ion is acid. So before we study acid, why should we study acid? Let's look at this. Why should we study this? So if you see this, the food products which we use, it has acid. For example, this citrus acid, right? I mean, most of the food products which we use has some acid. It's lemon. Lemon has acid. You see the medicines we have, the medicines we use, a lot of medicines which we use comprise of acid. They are acidic in nature. If you see our digestive system, right, our stomach, it has acid that helps in digestion. So it is a critical part of our body structure also, because the acid helps us digest our food. If you see, your mom must be using the bleaching powder to clean floors or to clean clothes. All those things has acid in it. The preservatives we use to preserve food, that also has acid. The fertilizers which farmer use also has acid. They are acidic in nature, actually, we can say that. The battery, if you see this battery which you have, the inverter battery which you have in a home, the water which is inside this, in charge, they are acidic in nature. The water itself is acid. It is also base. Also, we'll discuss this. The water is a funny case, so we'll discuss this case. But water is acid also. The perfume you use, please note, not deodorant. The perfume which you use is acidic. The deodorant is basic. Will explain that, but the perfume which we use is acidic, and that is the reason why you don't apply perfume on your body directly. You apply perfume on the clothes so that it should not harm your body, right? The perfume which you use is acidic in nature. So an acidic substance has a huge application in our day-to-day life, correct? And that is one of the reasons why we should study acid, so we should know that what all things is acidic and what is basic. So let's continue with the acid thing, and before we start the chapter, let's build the momentum of what is acid, how this acid came. Let's look into a brief history of acid. So it may not come from exam perspective, but it's good to know, and it creates a huge amount of interest in knowing how the acid word itself came. So this is the history of acid. I'll explain one by one. It started with Greek. Greek defined acid by reaction and taste. Anything which reacted vigorously and has a sour taste, right? They used to call as acid. So it was Greek in BCs. This used to happen in BCs. Very old, almost 2,000-3,000 years old. These guys used to say that, okay, acid are those things which react and which are sour in taste. Although very few number of acids were known that time, but they have this concept of acid. Then this guy Lavoisier came and he told, why only by reaction and taste? There should be something with the structure. There should be something unique with the structure for all the acid. And he told, let me define acid by structure. And he defined that anything which is oxygen is acid. Although his definition was wrong, but still the good part here was, till now we have been defining acid by reaction and taste, but this guy told, let me define by structure. And he told that anything which has structure is acid, because he took some compounds which were acidic in nature, and all that 10 or 12 compounds had oxygen. So he concluded that oxygen is the one which is responsible for acidic in nature, but he was wrong actually, he was wrong. But the good part for him was that he gave us an idea that, okay, we can define acid or base by structure also. This was the Lavoisier thing. Then this guy Davy, he did some experiments and he found some acids which doesn't have oxygen. And then he told, it is not oxygen for sure, right? But now we are in dilemma. We knew that there has to be something in structure which should define acid, but we don't know what is this, because Lavoisier told it is oxygen, but Davy found it is an oxygen, right? So this was the Davy period, 1829. See, if you see, they're not very old, maybe you see 220 years old, that's all, right? And then this guy Vaughan, he found in 1873, if you see, not even 120 years old, this guy told that it was not oxygen, it is hydrogen that is responsible for acidic nature of a substance. Using some experiments, he did some experiments, he took some acids and reacted, he found that hydrogen was something is common, and then he concluded, okay, hydrogen is the guy who is responsible for acidic in nature, right? Then till this point they were relying on solution, all right, of hydrogen's cations, and they were relying on water, because till now what they were doing was they had some solid thing, they used to put in water and then they used to create acid out of this. This guy Arrhenius in 1890, he told that we should not rely much on water, because they are substances, they are acid which doesn't need water also, right? And there he told that the substance which delivers hydrogen cations H plus ion to solution is yes. In this case, this guy is relying on water. No, in this case, relying on water actually. So I'm sorry for that. So this guy is still not relying on water. He's saying that anything when you dip in water, when you put in water, if it delivers H plus ion is acid. And this definition came in 1890, right? Where this guy is relying on water. This guy needs water for that. But this guy, Albert Ford, 1905, he found that he can still find acid which doesn't have water solution, right? There's no water required. So he generalized this guy's definition. That's all he did. This definition he took it generalized, so we can just ignore this part, not a great thing. Then this guy came, Lowry, in 1923. He gave a very good definition, and the definition is ability of acid to donate hydrogens to base, which acid. That means he defined both acid and base. Acid is something which donates hydrogens, and base are something which accepts them, right? So this guy Bronsted and Lowry, they're two people actually in 1923. They have come up with the best definition of acid and base, and if you see, it is not very old, almost 90 years old from here, right? So this guy had came up with the definition that anything that can donate hydrogen plus ions is called acid, and anything that accepts hydrogen plus ion are base. So if you see the definition change from Greek in BC's, Lavoisier, he came with the ideal structure, then Davy, then Arrhenius, and then finally Bronson and Lowry. So this is the most accepted definition for acid: anything that accepts, anything that donates hydrogen. So if you see, there's a whole lot of research involved. The definition just not came like that, right? It took almost, if you start from BC to 1923, it took almost 300 years to come up with this definition. So people did a lot of experiment. They spent their whole lifetime to find what is the ion and what is the definition, what is the common between all the acids, and they came up with this definition. So the reason why it took this history was so that you can appreciate the hard work involved in this to come up with a definition of acid, right? So with this we have the definition of acid, that is anything that donate hydrogen plus ion are called acids. For example, if you see in these reactions, you have HCl plus NaOH gives NaCl and H2O. So if you see that in this case, this guy has H plus NCl, let's suppose. So this guy has given his H to this guy, right? Hydrogen ion is lost from chlorine. If you see, chlorine got NaCl. Chlorine was linked with H plus, now it is with Na. So chlorine, this H plus ion is donated to this guy, right? Because if you see, this reaction is something like this: H plus Cl minus plus Na plus OH minus. You see this, what happened is this hydrogen ion is given to this guy. This guy is accepting the hydrogen ion, so this guy is a base. This guy is losing a hydrogen ion. This guy is an acid. So this becomes NaCl, because Na and Cl were left, so they combine, and H2, because OH plus H becomes H2. So in this reaction, if you see, this hydrogen ion was given to OH man, this NaOH. So HCl is an acid here. Why? Because HCl gave hydrogen ion to this base NaOH, because this guy acted. So we'll take the definition of base also. In this case, we can focus only on acid. So anything that gives hydrogen ion, so here it was H plus Cl minus, it gave this H plus, it becomes NaNCl. So it donated the hydrogen ion, so it is called acid. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.